2 to the power of 2, because the negative brings it to the denominator. Part C, we have got y is equal to sine to the power of 5 of x. You can write this one as, you can leave it like that, calculate it like that, or you can write it as this, to the power of 5. It doesn't make a difference if the 5 is outside or on the sine of x. How do you find the derivative of this one? Y prime is equal to what? It's like x to the power of 5, so that will be 5 sine of x to the power of 4. The power is decreased by 1, and then multiply it with the derivative of inside the bracket. What is the derivative of sine? It is cosine of x. So y prime is equal to what? Rearranging and simplifying it, 5 cosine of x sine to the power of 4 of x. We've got another example. Example 7. It says find, it says show that, let me write the question for you. Show that the slope of every line tangent to the curve y, that's equal to 1 over 1 minus 2x to the power of 3 is positive. So what do we have and what is required from us? We are given a function y that's equal to 1 over 1 minus 2x all to the power of 3. It's required from you to show that the slope of every tangent line to that curve is positive. Since it is talking about slope, what do we have? What do we know? We know that slope is the first derivative of the function. Okay, so we have to find, since it says show that slope is positive, that means we have to show that the derivative of that function is positive. Okay, so let's find the derivative of that function. Y prime is equal to, or let me first write this one as 1 minus 2x to the power of minus 3. I'm taking it to up, so the power changes to negative 3. Okay, y prime is equal to minus 3, 1 minus 2x to the power of minus 4. Okay, and then since this one is the composition function, so we are also multiplying it by the derivative of inside. What is the derivative of inside? It is equal to minus 2, because the derivative of this one is equal to 0 and the derivative of this one is equal to minus 2. Now let's rearrange it, simplify it. Minus 2 multiplied to minus 3, that's equal to 6, and I will bring this one down because it's a negative sign, so that will be 1 minus 2x to the power of 4. If you look at the derivative, what is that derivative? As we said, first derivative, that means we have found the slope. Okay, since it says show that slope is positive, that means we have to find the first derivative is positive. If you look at the first derivative of that function, I've got 6 over 1 minus 2x to the power of 4. 6 is always positive, and that bit, if you look at it, it's to the power of 4. It is an even number. Since it's an even number, positive or negative, if I have got here, it comes out as a positive number. So this one is positive, okay? That one is positive. Positive over positive is positive. So we showed that the slope of every tangent line to the curve, this one, is always positive. Okay, since the first derivative is positive. Now we are coming to implicit differentiation. Implicit differentiation. What is implicit differentiation? So far we have studied explicit differentiation. Why is it called implicit differentiation? Why explicit differentiation? It depends on the function that is given to us. Why? Because we've got two kinds of functions. Not two kinds of functions, I mean two ways of writing functions. Either the functions that are given to us are explicit or implicit. What is an explicit function? Explicit function. And what is an implicit function? An explicit function is a function written in that way. Y is equal to, for example, x to the power of 3 plus x over, for example, x squared minus 1. That's an explicit function. Why? Because y is written explicitly from x's and numbers that we have got, okay? Y is alone on one side and all the other things are on the other side. What is an implicit function? Implicit function is the mixture of both of them, okay? They are mixed up. For example, y squared plus x squared is equal to 5x minus 1. If you look at this function, it's given implicitly. Y's and x are mixed together, and y is to the power of 2. So that one is called an implicit function, and that one is an explicit function. So far, the differentiations, the derivatives that we have found were all explicit. Why? Because the functions that were given to us were all explicit functions. But now we are coming to implicit differentiation. So the functions that will be given to us are in that form, okay? X's and Y's are mixed together. Of course, finding that differentiation is easy because we are again depending on the rules of differentiation to find these ones. If you look at a function, if a function is given to me as y is equal to, sorry, not y is equal to, implicitly, y squared plus x squared, that's equal to 25. And if it is required from you to find the implicit differentiation of that function. Okay, let's look at it. We will find the differentiation implicitly. What is the derivative of y squared? Consider it as x squared. What is the derivative of x squared? It is equal to 2y. Okay, y squared, the derivative of it is equal to 2y. But since y is a function of x, but it is unknown here, I don't know what is the function y. So what will I do? I will simply multiply it with the y prime. So whenever you are taking the derivative of y, okay, in the implicit differentiation, you are taking it as you were doing for the x's that we have done previously. But you're adding what next to it? I'm multiplying it by what next to it? By y prime, okay? So the derivative of this one, y squared, is equal to what? Is equal to 2y, y prime, right next to it. Plus, what is the derivative of x squared? Simply, we know that that's equal to 2x, and that's all equal to 0, okay? If it is required from you to find y prime, okay, y prime is equal to what? We are doing the arrangements. To find y prime here, I have to take this bit to the other side, okay? So 2y, y prime is equal to minus 2x because I took this one to the other side. It's required from me to find y prime. So what do I have to do? I have to divide both sides by 2y. 2y goes with 2y, so y prime is equal to what? Minus 2x over 2y. Okay, and that is all about implicit differentiation. You're doing the same procedure that you were doing for explicit functions, but you're multiplying it with the y prime right next to it because y is also a function of x. We've got another example. It says find y prime. Okay, y prime is equal to what when y squared is equal to x. Okay, it's given to us y squared is equal to x, and it's required from us to find y prime. What is the derivative of this one? we have to find implicit differentiation. That's equal to 2y, okay? Derivative of y squared is equal to 2y multiplied to what? 2y prime. We said when we are taking the derivative of this one, we are also multiplying it by y prime. What's the derivative of x? That's equal to 1. It's required from us to find y prime, so we are leaving y prime alone, dividing both sides by 2y. 2y goes with 2y, so y prime is equal to 1 over 2y, and that is implicit differentiation. We are given another example. It says find the slope of the circle. Let me write it for you. Find the slope of the circle x squared plus y squared, that's equal to 25 at the point 3 and minus 4. So what's required from us? It is required from us to find the slope of that circle. That is the implicit function given to us. Okay, that's the implicit function given to us. It is required from us to find the slope. Again, since it is required from us to find the slope, slope is what? It is the first derivative of the function. So we have to find the derivative of this one, and then inputting instead of every x 3 and instead of every y 4. So let's find the derivative of this one. Derivative of x squared is 2x. The derivative of y squared is equal to what? 2y, y prime right next to it is equal to 0. Slope is required from me, so y prime is required from me. I'm taking the 2x to the other side. So 2y, y prime is equal to what? Minus 2x. Now I'm dividing both sides by what? I'm dividing both sides by 2y because I want y prime to be alone. This 2y goes with this 2y, so y prime is equal to minus 2x over 2y. That is the slope, okay, y prime. It is required from us to find y prime at that point. So what does that mean? That means I'm putting 3 and minus 4 into that function. Okay, so y prime is equal to what? Minus 2 multiplied to 3 over 2 multiplied to minus 4. Minus 2 multiplied to this one, that's minus 6 over minus 8. So that minus goes with that minus, simplify over 2, that will equal to 3 over 4, and that is the required. We are given another example, example 3, or before doing example 3, I will give you an example on my that I will do it for you, and then I will do example 3. Again, it will be required from you to find y prime, okay, if x multiplied to y is equal to 5, okay. We know if you have got x plus y, okay, if you have got, let me write it from you here, x plus y is equal to 5. How do we find that derivative? The derivative of x is 1, the derivative of y is y prime, that's equal to 0. So y prime is equal to what? Is equal to 1, okay. But here, if they are multiplied together, how do we deal with it? We are considering this is the product rule, okay. That one we will consider it as f, and that one we will consider it as g. So how do you find this multiplication? It is the derivative of the first one. Derivative of x is equal to 1 multiplied with g plus the derivative of g, that is y prime, multiplied with x, and that's equal to 0. Okay, what do we have? We have got f is multiplied to g. These are two functions multiplied together, so we are using product rule. So it is equal to the derivative of f, that's 1, multiplied to g, is y, plus the derivative of g is y prime multiplied to f, that is x, now equal to 0. Let's do rearrangement and finding y prime. So I'm taking this one to the other side. So y prime x is equal to minus y, okay, taking it to the other side. And then dividing both sides by x, because I want to have y prime alone. Y prime is equal to minus y over x. Now we will do the example that's given in the book, the lecture notes. It says find example 3. Find y prime if y squared equal to x squared plus sine of xy. Okay, xy is inside, is the angle of the sine. Okay, it is required from us to find y prime. How do I find y prime? Of course, I'm taking the implicit differentiation of that function. What's the derivative of y squared? It is 2y, okay, y prime right next to it. The derivative of x squared is 2x, and the derivative of sine is equal to what? Cosine of xy. But here the angle is not just x, so we also have to multiply this one by what? The derivative of inside. What is the derivative of inside? If I put it here, it is the multiplication of x and y. Okay, we did it previously in that example. So that one is equal to y, because first one is derivative multiplied with the second one, plus y prime and x. Okay, you can rearrange this one. 2y y prime is equal to 2x plus, I'll multiply this y with this one, okay, and that one with cosine of xy. So that will be y cosine of xy plus y prime x multiplied to cosine of xy. You know what we did here? I'm just doing the multiplication of inside the bracket. I wrote this one as it is, wrote this one as it is, and this is a bracket. I have multiplied it with cosine of x1. So once I'm multiplying this one with cosine, okay, once I'm multiplying this with that bit, okay. Now, of course, y prime is required from us, so we have to put the y primes together on one side and the other things on the other side. So 2y, y prime, I'm taking these to the other side, minus y prime x cosine of xy is equal to what? 2x plus y cosine of xy. What did I do? I just simply put this one to the other side, nothing else. Left this one here alone. I need y prime to be alone, so I'm taking y prime as a common factor. Here 2y remains, minus here x cosine of xy remains, and that part is the same as it is. I want y prime to be alone, so I'm dividing both sides by what? By 2y minus x cosine of xy, and dividing that bit also by 2y minus x cosine of x y. This bit goes with that one, so y prime remains as what? 2x plus y cosine of xy all over 2y minus x cosine of xy, and that is the required result. Okay, we are given another example, or let me say it's another subject, but again related to this one. We have got higher order derivatives in implicit differentiation. In explicit differentiation, we studied the higher order derivatives when we were finding the second derivative, the third derivative. Here in implicit differentiation, we also have got higher order derivatives. It is easy and nearly doing the same procedures that we were doing in explicit differentiation. In example 4, let's do example 4. It's required from us to find y double prime, okay, if y double prime is required from us, so it is the second order, second differentiation. If the function is given to us as 2x to the power of 3 minus 3y squared is equal to 8, okay? So first we have to find the first derivative of the function. What is the first derivative of that function? 2x to the power of 3, that is 6x squared, okay? I have got a minus sign here. That's equal to 6y y prime, okay? The derivative of this one is 6y with a y prime right next to it. That's equal to, the derivative of 8 is equal to 0. We have to leave y prime alone. We are required to find y double prime. So I'm taking this one to the other side. Let me write it here. 6x squared is equal to, taking this to the other side, equals to 6y y prime. Dividing both sides by 6y because I want to leave y prime alone. So y prime is equal to what? Is equal to 6x squared over 6y. 6 and 6 go together. Bye-bye. What remains? X squared over y remains. Of course, y here must not equal to 0 because if y is equal to 0, it makes it something undefined. Now we found y prime. Oh, what's required from us? Required from us to find y double prime. So we have to find the second derivative of that function. I'll write the page number 16. Okay. We know y prime is equal to what? Is equal to x squared. Y prime. We found that it's equal to x squared over y. Let me check it again. X squared over y. Okay, that looks like a quotient function. A quotient function, that one is f and that one is g. How do you find the derivative of a quotient function? F prime multiplied to g minus g prime multiplied to f all over g squared. So let's find it. Y prime is y, here we have got y prime, so I'm finding y double prime is equal to what? The derivative of f, that is 2x multiplied to g, okay, here I have written g as it is, minus the derivative of g. What is the derivative of g? It is y prime multiplied with f without any change, that is x squared, all over what? G squared, that is y squared, okay? Doing simplification, y double prime is equal to what? 2x y. Shall I separate them? Okay, I'll put this one on y squared and put this one on y squared. Minus y prime x squared over y squared. This y goes with that one, so y double prime is equal to 2x over y minus x squared over y squared multiplied with the y prime. Okay, I just put that y prime right next to it because I have to change it back to something else. Y double prime is required from us. Y prime shouldn't be in the equation, but I know that y prime is equal to what? We found it here. Y prime is equal to x squared over y. So instead of writing y prime, I'll write x squared over y. So y double prime is equal to what? It's equal to 2x over y minus x squared over y squared multiplied with x squared over y. Doing again rearrangement, 2x over y minus y squared multiplied to y is equal to y to the power of 3x squared multiplied to this one is equal to x to the power of 4, and y must not equal to 0. That's all about that section. Derivatives of trigonometric functions, implicit differentiation, higher order implicit differentiation, how to find the derivative of composition functions. Okay, where was it? Okay, chain rule, the derivative of composition functions. I hope you would understand what I'm explaining for you. Have a good time. Bye bye.